Okay, so this is question 5 for June 2014 for the Edexcel paper. Now this question is quite simple, and I just want to point out a few things. Not at all, so I can put the charger on my camera and save up, put some time aside to do that and make myself not look like an idiot for not being prepared, which of course I wasn't, of course I am, sorry, prepared. I just wanted to mention a few things about this question actually before we get started. Now this question is it's fairly simple. All it is just requiring your use of algebraic fractions. Now, for those people that are watching this as after they've completed or doing C4, the first topic of C4, which is partial fractions, this is quite a key thing that you need to put yourself in the mind of C3, because guess what? It is a C3 exam, weirdly enough. I know, it's amazing. Yeah, so anyway, for this question, you have to remember we're in C3, and in C3 we do oh my god. We don't do oh my god, I just almost said partial fractions. Bad as hell. So anyway, what you do in C3 is we do something called algebraic fractions and not partial fractions. And the whole concept of this algebraic fractions is to find common denominators, simplify and cancel them out, or just generally work out the simplified fractions. Now, partial fractions are working back from this, so to speak, in C4, whereas they are related, as they are related topics. But anyway, that was just a bit of waffle, so I could explain what to watch out for. So the thing to watch out for in this is, you've got to remember, we are doing algebraic fractions, not partial fractions. So because the question says, we're given a function of g of x, and it says g of x or gx is equal to x over x plus 3. That's x over x plus 3. Obviously, I'm assuming you've got the question paper next to you, or whatever. And we're told that is plus 3 brackets 2x plus 1 over, sorry about the pen by the way, x squared, take x, oh sorry, it's plus x, take 6. And it says, simplify that so it's equal to your x plus 1 over x take 2. Let's see, my bachelor power things are terrible, they really are terrible. Anyway, God's sake, charging everything up. Your battery is terrible. Anyway, waffling on. So it said that show that g of x is equal to x plus 1 over x take 2, and we're told x is bigger than 3. That isn't relevant for the moment. But anyway, as I said, this needs to be remembered that it's algebraic fractions, because otherwise you'd probably start trying to split that one up into partial fractions, so you could give them all a common denominator. Well, you don't need to do that. The things you need to spot, okay, we've got a quadratic on the bottom here. So what we do is we'd factorise that. However, before we factorise that, I just want to point out another thing. When we factorise, if you're having trouble factorising this, obviously, which most people don't, but sometimes even I, you know, the greatest guy in the world at maths, has trouble factorising this. X squared plus x takes 6. The other denominator, x plus 3. Generally, this is not always the case, but it's a good starting point if it's just in your mind you can't factorise that. And obviously you could go to working out the quadratic formula, but if you're too lazy, this denominator of this side, x plus 3, it's either going to have a factor of x plus 3 or 2x plus 1. Now it's not going to be 2x plus 1 because x squared doesn't require the use of x and 2x, or because it won't work. So therefore, it's probably going to have a factor of x plus 3, because as it's only worth it's worth 4 marks actually. Generally, what will happen in these kind of questions, and what happens prevails in this question exactly, is you'll have one fraction will be with one factor, and then the other will be with 2 factors on the bottom. So basically you'll have the same factor, but one fraction that you're adding to will have one more fraction, which you just have to times the other fraction by the common denominators. So you can add them. So if that's too much, well, it will become obvious as we go along. Okay, so g of x, okay, so first of all, the first job before we do anything is simplify it in terms of factorising it. So, therefore, just rewrite out the first bit as normal, and then we factorise this, so you're going to put x and x. Now, as I said, your general factor is going to be the denominator of the other factor, which it is. That's going to be x plus 3 and x take 2 to get x squared plus x take 6. So therefore, we've got a common denominator of x plus 3. However, on the right hand side, we've got x take 2. So we're left with what I was saying before, where we've got 2 factors on the bottom of one fraction and only one of the factors on the other fraction, on the denominator of the other fraction. So what we need to do, we don't need to times this 3, the second fraction, because that's what most people would do. Most people would go, okay, so I'm times this by something, I must times the other fraction by something. Well, you don't need to, because this fraction is already times by x take 2 and x plus 3. That's why the exam boards love this type of question where you've got 2 factors on one denominator and only 1 on the other, because it will catch out the students who are really either really nervous in the exam or not paying attention to the question, because the exam boards are mean, they're nasty people. But if your exam board's watching this, and you're going to be marking my exam, please, they're really, really good. Really good. Sorry, I've covered myself there, hopefully. So anyway, we said, because this has got 2 of the factors, and this has only got 1 of the factors, we need to times this by the other factor that it hasn't got. That's on the denominator of this fraction. Well, there's quite a lot of f's in there. Anyway, so we times both the numerator and the denominator of the first fraction by x take 2, because that's what it hasn't got. X take 2. We don't remove this other factor, so x plus 3, x take 2. Now we could do that all over 1, x take 2, x plus 3, but I'm just splitting it up to show you, so you could skip this step out if you wanted to, and I probably would advise it in the exam, because you don't have a massive amount of time. And then that is plus, now you could expand this if you wanted to, but I'm not going to yet. So as I said, all we've done is times this fraction by x take 2 over x take 2, because that's the same times it by 1, but we've given them both the same denominator. So therefore, we put this all over one factor, like you probably did before. So it's x plus 3, x take 2. The first one is going to be, so I put these in square brackets on top, so not all taken away. So the x times x is going to be x squared. X times minus 2 could be minus 2x. Take away 3 times 2x is going to be 6x, obviously, and plus 3. So therefore, if we simplify this down, remember, you've got to keep an eye on what we want it to be. We want it to be x plus 1 over x take 2. So you know how far we have to go from that, obviously. So the factor on the bottom is going to be x plus 3 and x take 2. Now my sixth sense is telling me we need to get rid of this x plus 3. Well, the first thing we need to do, because obviously the denominator of the fraction we're trying to get is some x plus 1 over x take 2. So the top needs to be x plus 1, bottom needs to be x plus 2, obvious. But we need to simplify the top first. So therefore it's going to be x squared, because, so simplify this, x squared, take 8x, and you take away 3 from that. So because we've got a quadratic on the top, the first thing that most people do, and indeed what you do, is you factorise it. So you do x, brackets x. Now, what I'd like to see here is this be x plus 1 and x plus 3. Unless I've, oh great. Oh, it's plus, damn it. Not read the question right, that's just proved. So it's actually plus 4x. Yeah, it shows I'm not even I'm not reading this question right. So, yeah, if you follow me, I put a negative there because I was in the mind of the quotient rule, which obviously is irrelevant. That's one of the things you've got to remember. Keep focused on the question, which I didn't. So I did that on purpose to see if you're awake, obviously. So anyway, if we simplify that, we get x squared plus 4x take 3. So we factorise that, it's going to be x plus, see that's why, actually, yeah, sorry, yeah, so it's x plus 3, is that right? Yeah, x plus, oh sorry, x squared plus 4x plus 3, so it's x plus 3, x plus 1 over x plus 3, x take 2. So, the reason I knew I was wrong there, not because I was looking at the answers, but because I knew it was x plus 1 over x take 2. And as I had x plus 3 on the bottom, I knew one of the factors on the top had to be x plus 3. So then the other factor must have been x plus 1, because if the x plus 3 is cancelled out, then the other factor must have been x plus 1, because that's what we're left with on the numerator. Now if you knew that, and you knew the bottom is x plus 3 and x take 2, or the denominator is x plus 3 and x plus 2, then in essence, if you wanted to cheat a little bit, if you didn't know how to do this, you could work backwards in essence. So if you knew it was x plus 1 over x plus 2, I mean the bottom is x plus 3, then the other numerator must be x plus 3. So you could work backwards, expand it out, almost. So if you didn't know how to, if you got it wrong and simplifying it, you could spot where you went wrong. So that's what I did just then in my head. So that's how I worked out that I was wrong. So just a little bit more information. As I said, I could have just done that answer there, and obviously I did that on purpose to show you, you know, how you could go wrong. The next question is a little bit more thinking rather than maths. So it's part B. So it's 5B, and it says find the range of G. Now, domain and ranges, we have to go back to what domain and ranges are. Now, I don't necessarily have to draw the diagram and I think, okay, what a domain and what a range is. Well, domains always come first, because it's the D is the first, well, no, it's the first letter in the alphabet. It's before the range R, so therefore the domain must be the X value and the range must be the Y value. So therefore, the range must be something to do with the Y values. Now as we're told, X is larger than 3, and this is equal to X plus 1. Oh, sorry. Just realised I hadn't put the switch to charge on. Anyway, so X plus 1 over X take 2. And if X is larger than 3, what's a range of g of x? And if g of x is the y values, then therefore y is equal to x plus 1 over x plus 2, x take 2, sorry. And if x is larger than 3, we put x to be 3 into this equation, so that's 3 plus 1 over 3 take 2, which is obviously 4 over 1, which is 4. Yep. So if x is larger than 3, then it has, then y, because we've got x is 3, to get a value for y, that y must be greater than, because x is greater than 3. Instead of putting x there, we should have put x is greater than 3. But just for simplicity, I just left as x is equal to 3, but obviously it's not, x is greater than 3. So if x is greater than 3, the y coordinate when x is 3 must be 4, as we've just proved. So therefore, y has to be greater than 4. And we use the same sign as we do for x's, and because x is not equal to or larger than 3, and it's just simply x is greater than 3, then y must have the same sign, inequality sign. So the next question is a little bit more, well, it's worth a few more marks, so I'll just rub out, just give you a second there to sort of copy that down. As I said, it's on the mark scheme anyway, so but that's how you'd work it out. Alright, so just give you a second to copy that down, and then we're going to go to part C, which is a little bit more challenging. Alright, so hopefully you've got that down. We're going to move on to part C now. Now part C is a little bit more complicated. Let's see what, it's flashing at me. Oh great, we've got a minute. So better hurry this up. So we're told the value of g of a, which is the same as g of x, but we put a where x is. Oh god, I need to hurry up. Is equal to the g minus 1 of a. So therefore, we need to work out what g of a is. And I'll just quickly do this in. So when we had y is equal to x plus 1 over x plus 2, we put g of a, so we put a is where x is. So therefore, is a plus 1 over a take 2. And that is equal to 1 plus... Oh yeah, sorry. So that is equal to g, the minus 1 of x. Because that's g of a, and then that's g of minus 1. So, we had, as we were saying, this is g of a, and we're told that it's equal to g minus 1 of a. But we're not told it's equal, we're asked to find the given value of a. Right. But so obviously what we need to do now is find g of x. Now we know g to the inverse g, the inverse of g of x. So first we have to remind ourselves what g of x was. Now we said g of x was equal to x plus 1 over x take 2. Now the way I think of doing an inverse is, obviously that's y is equal to x plus 1 over x take 2. Switch what they are round, so therefore it's x equals y plus 1 over y take 2, and then try and get y to be the subject, and then change it back to x. So basically, if you're doing it back again twice, that's the way I think of it. It's quite confusing, but you know, if you have any other ways, just let me know, and I'll try and explain it in that way. So therefore, is x times y take 2 equals y plus 1. Expand that out. So xy take 2x is equal to y plus 1. Therefore, as we said, we want to make y the subject. So, sorry, just think of this for a second. Yeah, so therefore, they got y take 1. Sorry, one sec. Yeah, you want to make... No. What? So I'm just trying to work out what they've done there. I seem to have skipped a step. Well, what I've done, sorry. Obviously what I've done. Sorry about this. They've got y is equal to 1 plus 2x over x take 1. And then obviously what you do is that would be the g minus 1 of x is equal to 1 plus 2x over x take 1. Okay? So if you got that, then hopefully that's a good thing, because I kind of messed up explaining that one a little bit. So as we said, we wanted to make y the equation, y the subject to the equation, and then change it to x's. So hopefully, as I said, that made some kind of sense. If it didn't, don't worry, because I didn't explain it very well. Now, as we said, this x is equal to a, because this is equal to g of a. So it's essentially g to the minus 1 of a, because that's what the question says. So therefore, it's a plus 1 over a take 2 is equal to what we worked out over here, except as we know x is equal to a, so it's 1 plus 2a over a take 1. Okay, so that's the equation that we've got to try and simplify. So what we do is we times both sides by the denominator of the other one, so this will make it equal to each other. So we times them both by a take 1, then both by a take 2. So this gets us a plus 1 times a take 1 equals 1 plus 2a times a take 2. And then you can expand this out if you want to. So that becomes a squared take a plus a take 1. So the plus a and the negative a cancel out, so it's a squared take 1 So this is equal to, if you expand this one, so that's a take 2 plus 2a squared take 4a. So then we simplify that down. So you're still left with the 2a squared. Let's take 3a, take 2. So then you would simplify that down further. So that 0 equals, because it's how we solve quadratics, obviously making it equal 0, standard stuff. So it's a squared, because you're taking an a squared away from both sides, adding 1. So that therefore it becomes 3a minus 3a plus, take 1, sorry. Because you're adding plus 1 to the minus 1, minus 2. So that's what we end up with. However, this is not found out what a is, so we need to factorise this. And obviously we're going to get two values for a. So therefore, a, brackets, a, close brackets, and it's going to be negative. Oh, sorry, yeah. This is probably just going to be quite difficult to factorise. Well, we'd have got onto that in a minute anyway, because what we need to get is we need two numbers that times to minus 1 and add to minus 3. It's going to be a little bit tricky. They're going to be fractions. So what we can either do at this stage, we can do a number of things. We can either use the quadratic formula, we can either, so obviously we're not going to factorise it because we get ourselves in a mess doing that one. So then obviously yeah, this goes back to C1, why it links on to each other. So we can either factorise it, complete the square, or use the quadratic formula. Now, I'm going to use completing the square. So, remember what completing the square was? It's a squared, take 3a, you half the 3, which is 3 over 2, square it, which is plus 9 over 4, you take 9 over 4, and then you add, sorry, take 1. And then you always half the middle number, so that's, and then, so it's a, take 3 over 2, squared, and then you simplify that one, so minus 9 over 4, take 1, so minus 1 is minus 4 over 4, so that becomes minus 13 over 4, and that equals 0. So then what you do from there is going using C1 stuff, so therefore you'd make a take 3 over 2 squared equal to 13 over 4, so a equals a take 3 over 4 equals plus or minus the square root of 13 over 4. Obviously that would equal root 13 over 2 if you want it to be precise. Well, actually you could do either way. That's what they've done on the exam sheet. They've said root 13 over 2, but you could easily have root 13 over 4, but it's a bit less specific. So therefore, if you move this across, so a is equal to 3 over 2 plus or minus root 13 over 2. So that's your answer. However, as we are told at the beginning of the question, a is larger than 3. And if a is larger than 3, you have to think realistically, what is root 13 over 2? Now, to work out what root 13 is without a calculator, well, actually, you could put it in your calculator, but, you know, root 13, it'll be, because root 9 is 3, and root 16 is 4, so it's going to be about halfway between 3 and 4, so it'll be 3.6 something over 2, that's going to be about 1 point something, and 3 over 2 is 1.5, so if a has to be larger than 3, 1.5 take away anything is obviously going to be less than 3, so it can't be 3 over 2 take 13 over 2, so therefore it must be, even if you worked it out, a is 3 over 2 plus root 13 over 2. So that last little bit of question 5 was a little bit more confusing, so I do apologise in the way I explained it. I didn't explain it very well, but I think this way is a little bit confusing. I would have just gone straight to doing, y over 2 equals y plus 1 over x, but you know that's the way they did it, so that's the way I would try to explain it to you, because obviously I don't know, personally I think this method is a little bit more confusing. So if you have any other methods you want to pass across that end up with the same answer for the inversity of x, then please do comment, and I will try and explain it in that way to other people, so you are helping other people. So that's the end of question 5. We'll be moving on to question 6. There's still 3 more questions to go. This is quite a lengthy paper, so we'll see you in a minute.